if I have holes somewhere, I need to fill them out. So if we haven't done 18, 19, and 21, I'm guessing that was ones you were supposed to do on your own. We should do that. So this is page 4. Do you want to do these for practice? It says write the prime factorization of this number. You will have to write prime factorization. I don't have staples, sorry. My stapler ran away on Friday. Just make sure your name's on all your pages. I know, it's a 3-hole punch. So you will have to know the prime factorization. So the first thing you do is you make 2 branches, right? What 2 numbers multiply together to make 96? No, 10 and 9 would be 90. 3 and 32. That would work. If you're looking for something on your table here, 12 and 8 make 96. So let's pick one that we could easily find, right? You see how I found 96 here? Because when I'm trying to find the factors of a number, I'm looking for where the multiple is and then finding the 2 numbers that multiply together to make that 96. Do you see that? And this is also one we should know because we should know our 12s. So what are the I just need 2 factors that multiply together to make 12. 3 and 4, I like it. And then I need 2 numbers that multiply together to make 4. 2 and 2. Remember, we can't use 1 in the number here. Good. So I'm going to write 2 and 4 because I don't have much room over here. And then I have what? 2 and 2. It's been a hot second since we've done these, but do you remember I have a factor of 2? Well, I could write this out first. So you would write it out. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So sometimes it might be helpful to circle all these, right? Where did 1 cancel? We only have 1 number that we're doing the factorization for. Do you see this? We only have 1 number. 4. There's no 4s here. The 4s are not prime. Remember, the 4s we broke down. Okay. We're just taking the prime numbers. I just haven't written the 3 down. Relax. We had a question about the 4s. All right. So remember, we use a base of what? How many factors of 2 do we have? 5. So that is my exponent. And then I'm showing times 3. Okay. Does that make sense? All right. Try number 19 if you have not. I want to see it. I want to see that you know how to do this because you're going to have to do it tomorrow. You're going to have to do it tomorrow. Tomorrow is not going to be a gimme quiz like the last quiz that I gave you the questions. I gave you the answers. I gave you the work. I made you practice it digitally. And then I gave you the quiz that was the same as the practice. It's not going to be a gimme like that. You guys got to know how to do this. Thursday. Next Thursday. Oh. The 17th. 700. How do I do that? Which I could have, I'm not sure. All right, give me two numbers that multiply to make 700.
70 and 60.
70 times what? 10. Guys, we gotta know how to multiply. If not, we're working hard at home. Real hard. Two and 350 would be fine. So it might look a little different, but it should end the same. Some people might say 7 times 100. That's fine. That works too, right? So if I have 70, I would say 2 and 35. Right? So I'm not sure what happened to your 7, Finley. 7 times what? 5. Not sure what you did. I'm gonna have to come back and look. And then this is 2 and 5, right? So what's another way you could have done this? Somebody said they did what? 2 and 350. So this makes it a little harder. What did you say then? 7 times 50. And then this would be 2 times 25. And this would be 5 times 5. Okay. So any way you look at it, we have how many factors of 2? Times how many factors of 5? Times 7. So that should be our answer for that. So be really careful when you're splitting these numbers. 294. I'm gonna look here. Try and find 294. Bueller, come on, help me out. Ooh, this multiplication table is not helping me out. So I'm gonna figure out what I could divide it by. Well, 6 plus 9 is 15, so I know I could divide it by 3. So I might think, hey guys, how many times can 3 go into 29? 9, good. 9 times 3 is what? Do you see how you need to know how to multiply? How many times does 3 go into 24? 8. So this is 98. Let's see if I can find that here. 98. There's a 96. Here's a 98. 14 times 7. 7 times 14. Now we can do that, right? What two numbers multiply to make 14?
7.
Good. 7 and 2. So I have a 2 times a 3 times a factor of 7 twice. All right, while we are looking at factorizations, make sure you have these notes. These notes are very importante. So let's find, I think I'm just gonna give you another piece of paper real quick. My goal right now is to give you some freebies. So should you write this down? Yes. So, I'm going to pick some things straight from the quiz. You can slide this piece of paper into your packet and use this on the quiz, right? Papers are totally allowed on the quiz. Can you use your phone, your friend, anything like that? No. But these notes mean that you're doing your job in class and you're totally welcome to use them, right? So we're gonna use our resources here. All right, so prime factorization. This is, I'll give you the bigger one. Let's do the bigger one together. 1, 1, 8, 8. So when I look at this, I start thinking of my divisibility rules, right? It ends in an even number, so it's divisible by 2. So I could divide this by 2. But when I see it again, I'm like, oh, I could just divide this by 3, which helps a little more. Or 88 is divisible by 4, so I could divide it by 4. What do you want to do? You want to divide by 2, 3, or 4? 3? Okay. So if I'm dividing it by 3, right? If 3 is one of my factors here, how many times can 3 go into 11? Almost 4, but not enough, right? So this is 2, bring down your 8. How many times can it go into 28? 9 times, because 9 times 3 is 27, right? Then I'm just subtracting. Then I'm bringing down my 8. How many times can 3 go into 18? Guys, you should know these. Yes, 3 times 6 is 18. So 3, 9, 6. These are really nice multiples of 3, right? 3 goes into 3 once. 3 goes into 3 3 times. 3 goes into 6 twice. So that was beautiful. 132, not 1, 2, 3. Be careful. I know it's even, so I could divide by 2, but I also see it adds up to 6, so I could divide by 3. If it's divisible by 2 and 3, I know I can divide it by 6. So 6 into 132. How many times can 6 go into 13? 2 times, which is what? 12. Bring down that 2. We just said 2. So 6 and 22. This is getting smaller to a point where we should definitely know what to do now, right? What would I split my 6 into? 2 and 3. Good. And 22. 2 and what? 11. Very good. So if I was writing the prime factorization of 1188 SJ, I would say I have how many factors of 2? So 2 to the second power times how many factors of 3? 1, 2, 3. 3 to the third power times, don't forget about that, 11. Remember, you might have to. Oh, you don't have to. I thought you were gonna have to find a composite number, but you don't, so we won't even go over that. All right, so let's look at the greatest common factor. So your first side, you simply have factors. Then you're breaking a group of 156 students. So at least 4 in a group. So let's do factors. This is going to be a group of 156 students. So it has to be at least 4, no more than 12 in a group. At least 4, we're grouping 100, I should say grouping of 156 students. So we have to have at least 4 in a group. If we had 4 in a group, how many would we have? 4 students So what is 4 into 156? I don't know if this even works. I don't think it does. It's even, it's divisible by 6. I don't think it's gonna be divisible by 4. Oh, wait, just kidding. Look, how many times does 4 go into 15? Almost 4, so only 3, which is 12. Bring down your 6. 4 times what is 36? 9. 9 times 4 is 36. So 9 groups of 4 students. Does 5 go into this? Nope. Does 6 go into this? It should, because it's divisible by 2 and 3. So if I'm taking 6 into this, they sure didn't make this easy for you, did they? How many groups of 6 go into 15? Only 2 without going over, right? So this is 12. Again, how many groups of 6 go into 36? 6. Oops, I screwed this up. This isn't 9 groups. This is 39 groups. Who's supposed to be yelling at me? Thank you. So 26 groups of 6 students. Will 7 go into this? No, 7 will 8. I don't know. Yeah. Will 8 go into 156? 8 into 156. Just once would be 8. This is 7. And no, 8 will not go into 76. So no 8. How about 9? Do these add up to 9? 6, 7 plus, no, it adds up to 12, or 1 plus 2, which is 3. So it's not divisible by 9. It's not divisible by 10. Is it divisible by 12? That's one I can look for. It is. 12 times what? 12 groups of 13. So we could do 13 groups of 12 students. But they said they want no more than 12 in a group. So I think that's it. That's all we have to do. So make sure you've got this down. 39 groups of 4, 26 groups of 6, 13 groups of 12. I'm going to give you another minute because questions on how we got this? Wait, like you weren't writing these down before and now you have to spend 5 minutes doing it because you chose not to do your job when we were supposed to? All right. So much work. Here's what you're going to have to know on the back side. Are you ready? You can turn your sheet over if you want, if that helps you, because it's on the back. You need to know the greatest common factor of 24 and 78. And you need to find the greatest common factor of 70 and 126. You can do this with prime factorization. You can do this with listing the factors. Any way you want to do it. All right, so I'm going to leave some room here in case you want to do that, so you have it for tomorrow. the other things you need to know are the least common multiples of 8 and 26 and 15 and 70. So make sure here you're listing multiples, right? Multiples. That's us counting on, right, James? And this F stands for factors. All right, I'm gonna read the word problems to you, and we're gonna figure out together what we would do, okay? Are you ready? The field hockey team and the soccer team. Is everybody done writing these, or can I just? Okay. So the field hockey team and the soccer team shared a field at their last practice. If the field hockey team uses the field every 4 days and the soccer team uses the field every 6 days, how many days after their last practice will they share the field again? So are we talking factors or multiples? Multiples, good. So this is a least common multiple problem, and we're trying to find the LCM of, you might want to write down LCM of what? 4 and 6. You can do that. You can list the multiples of 4 and 6. This is not in your packet. That's why I'm telling you to write it down here, right? You could write down LCM of 4 and 6. You could even write the problem number, right? Because I'm giving it to you. That's what you're going to do for 14. Can you list the multiples? Yes. All right, if Sierra baked 80 chocolate chip cookies and 64 sugar cookies, she would like to equally distribute each type into containers. What is the greatest number of containers she will need if no cookies are left over? Are we finding the greatest common factor or the LCM? Yes, good. Greatest common factor. This is the greatest common factor of, and what two numbers are we using? 80 and 64, good. Finally, the PE department, can you guys please stop the conversation? Thanks. Yeah, I know you're talking, you're not supposed to be. The PE department is buying tennis balls in packs of 18, golf balls, oh, we've seen things like this. Golf balls in packs of 12 and soccer balls in packs of 4. They wish to have the same number of each type. This is a 2-part. So what is the minimum number of packs of soccer balls they must purchase? So first, we're finding the least common multiple, right? So for number 16, we're finding the least common multiple of, there's 3 different things, 18, 12, and 4. This is your big 18 and 12 and 4. And if these are the soccer balls. So the second part B of the question is how many packs of soccer balls do we need? All right, let's do this one before you have to go. That way you'll feel confident in this. So least common multiple of these few things here, 18. This is the least it can be. So let's look at the multiples of 18. 18, 36. Can 12 go into 36? Yes. Can 4 go into 36? We should know that 4 times 9 is 36. So 36 is the LCM. But this is only part A, right? This tells us how many soccer balls we need. If we need 36 soccer balls, how many packages do we need? We just said what times 4? 9. We need 9. And remember, I love it when you label, hint, hint, hint. I love it when you label 9 packages, 9 packs. All right. So that is the last thing you definitely want to get down. I would hold on to this somewhere safe. Put it in your Chromebook if that stays with you. I would do these problems before the quiz tomorrow. If you need me to hold on to your packet, you may put it on the yellow folder. You need me to hold on to this paper that doesn't have much on it yet, right? Because you got to finish doing some of those to practice. Be ready for your quiz tomorrow. Calculate.